Hello everyone, welcome to this brand new lesson. In today's lesson, we are going to talk about text classification with Huggingface transformers. And basically we will be using here a DistilBERT model. Otherwise you can also use any other Huggingface transformers and you can follow along with this video lesson. So before that, let me explain you a few more things. The first thing which I'm going to explain here, we are going to use a fetch 20 Newsgroup data. All right, so this data is available at scikit-learn here at this address. All right, so I'm gonna just copy it here and then I'm gonna paste it here. Let me make it here dataset. All right, so this dataset we are going to use. Thereafter, once we use this dataset, it says that we have here 20 classes. Total number of samples are around 18,000 and there is only one dimensionality and the feature is text data. And if you want to see this dataset in details, you can see it into a Kaggle. So at this address here, let me share this one as well. All right, so this is going to be a Kaggle link. And at this Kaggle link, you can set, you can see here details about this dataset. This data says that it has a list of these 20 news group. All right, so these are the graphics, MS Windows, and the PC hardware Mac, IBM. So these are kind of the dataset which is discussing about these topics. Like in the sport, it discusses about the baseball and the hockey. And in the science, it discusses about the electronics, medical and the space. So all those things, all right. And thereafter, these are the these document, text data document, which is being discussed here. All right, and this is complete data set. For example, here for a medical in science group, and this one is a complete data set and it is discussing about this medical information. So this whole text data. Overall architecture which we are going to design here, that we will be passing a text data as the input, and then there will be a BERT model in between, and then that BERT model will be doing internal tokenization and classification, and then finally we will be getting our target output on the test dataset and the validation dataset. And of course we will train our model on the training dataset. All right, and the pre-trained model, that's mean the transformers which we discussed earlier, that we will be using these transformers. You can get these transformers from here. Let me pre-trained models. So this is going to be the pre-trained models link. All right, superb. So these are the dataset which we are going to download from sklearn, and details about this dataset is present on Kaggle, and pre-trained model is available at this Huggingface.co transformers. All right, so we can use any of these models, but here for the simplicity, I'll be using a DistilBERT model. You may ask that why I can't use other models like BERT and other. Because these models are pretty much large model, and the large model takes a lot of the time. And in this video, I don't think that you will be waiting for more than hours and the 2 hours to get your models trained. So that's why I'm gonna use here a DistilBERT model. So with the help of the DistilBERT model, we are gonna learn about the concepts. And apart from that concepts, you can just change these names apart from the DistilBERT, then you will be also able to use other models as well. Although those models might take some times in training. So I'm gonna use here a DistilBERT. All right. Perfect. So I think I'll be using here DistilBERT base uncased model. All right, so this model I'm gonna make here my base model. All right, superb. So these are the introduction. Now let's go ahead and set our Google Colab notebook. If you don't know how to work with Google Colab, you need to visit their colab.research.google.com. Thereafter, in file, open a new notebook, and then you will be getting something like that. You can change its name and the headings, other things. All right. Thereafter, you also need to set here a GPU hardware accelerator. Otherwise it will take a lot of the time for training. All right, so let's go ahead and start working with our model. So the first of all, we are going to install ktrain. All right, so pip install ktrain. Ktrain is a wrapper library, and this one is wrapper for TensorFlow and Keras. So this ktrain we will be using for our Huggingface transformers use. All right, so it might take some time, and currently we have ktrain version 0.23.2. That's mean if you get your ktrain is not working, then you can install specifically this version of a ktrain to get it working, because currently at the time of making this video only ktrain 0.23.2 model is available in the market. All right, while it is training, we can do some other settings. All right, so there are few settings, I think. Yes, while it is installing, in fact, not it's training. So installation is done here. Thereafter, few more things I'm gonna use there, and those things I already have, so I'm gonna just copy and paste it here, then I'll explain you there. So there these are some settings where you want to set for your GPU use, and plots etc will be plotted in line of the notebook. So these settings are required to make it properly work. Let's go ahead and run it. Thereafter, once it runs, then everything is on the place. Now we can load our dataset. All right, but before that we are going to import here sklearn dataset and ktrain. So import ktrain. Thereafter, from ktrain import text. That should be there. Import text. Thereafter, from sklearn dot datasets import, we have here a fetch 20 Newsgroup. All right, so only these Python packages we will be needing. And once we imported all these necessary packages, let's go ahead and load the dataset. Do remember, we are going to load this 20 Newsgroup data from the sklearn, and total it has 20 classes, but we are not going to use all those 20 classes, but we are going to use only few classes. So I'm going to say here these are the categories, and the categories which I'm going to use here alt dot atheism. All right, thereafter social, and then we have here this religion, and then I'm gonna use here Christian. All right, then here we have comp dot graphics, and then SciMed. All right, so these are only I think these are 4 only, perhaps. Okay, so these are only 4 groups, and let me see few more. I think we can use sports, perhaps. Yes, let's go ahead and use this one, and there. All right, so let's go ahead use these 5 only. So we'll be using only these 5 categories. That's mean what we are going to do. We are going to pass here the set of classes. I mean the data set for which set of classes we want. So instead of downloading all the 18,000 rows, it will download only those dataset which have these classes. So by doing this, we are going to save some time in total classification time. Alright, so we have their categories. Let's go ahead and get the dataset. Alright, so the first of all, I'm gonna get here the training dataset. So the train dataset is their fetch 20 Newsgroup, and in that I'm gonna pass here the subset of the dataset, and that I'm going to get the training subset of the dataset, and thereafter it asks about the categories, and there on the categories we have here this categories. All right, that's mean import these 5 categories dataset, and thereafter I'm gonna set here the shuffle is equal to true. That's mean this is going to randomly shuffle all the dataset which is imported, and thereafter I'm gonna set here this random state, and random state I'm gonna set here 0. All right, so this random state is random. You can set any random state. I'm setting random state to 0 so that I can reproduce same result whenever I run this cell. All right, so with this I have got there a training data set, and similarly as I get this training data set, I can do for the test data set, and their subset I'm gonna use a test subset, and apart from that every other things will be same without any changes. So we have got the train dataset and test dataset. All right, now if you print here this test dataset, all right, so once you print, you get something like this. It says that okay, the this notebook data limit is exceeded, so this cannot be printed. Moreover, it has dot data and dot target. Otherwise, one more thing you can say that test dot keys. All right, so this test dot keys says that we have a data, file name, target and the description. All right, so basically we are interested in the data and target variables. All right, so these are the data and this one is the target, and if you want to print there, you can actually print this target, and in the target name you will be getting those categories. All right, so it's a simply like this, it's target names. That's when these are the labels, and these are 5 labels which we have imported in our notebook, and these labels we are getting there. And similarly you can also test for the training data set without any issue. All right, now I have here x train is equal to train dot data, and then y train is equal to train dot target. Then I have here x test is equal to test dot data, and then here y test is equal to here we have a test dot target. All right, superb. So these are the 4. All right, so x train dataset, y train, x test, and the y test dataset. That's when we have got the dataset. Let's go ahead and check the shape of this dataset. X train dataset and x test dataset. All right, so shape is not available because these are already lists, so we cannot get the shape. But instead of shape, perhaps we can get the length of this dataset. All right, so it says that total 2,800 54 we have in the ktrain and 1899 in xtest. All right, so xtest is a little smaller than the ktrain. So these are the text data. I'm not sure if it is able to print. Yes, so this can print, although this is huge data set. So I'm just simply going to comment that one. All right, so we have prepared our data set. Let's go ahead and build our transformer model. All right. All right, so there I'm gonna build this transformer model. All right, so if you remember, I had told you that I'm gonna use this DistilBERT uncased model. All right, let's go ahead and copy it, although you can use any other models, but I'm selecting DistilBERT model because this model is small and it runs faster. Its training is fast, so that's why I'm gonna just select that one. All right, so there I have model name is equal to DistilBERT uncased. So this DistilBERT base, that's mean this one is a smaller version of DistilBERT model. Uncased means it is case insensitive. That's mean lowercase and uppercase doesn't matter. All the data gets converted into the lowercase of the data. All right, let's go ahead and get the transformer. So there I get their trans is equal to text dot transformer. All right, so there we get the text dot transformer, and in fact let me make it a small model name. So I'm gonna get there the model name. All right, thereafter this model name is equal to model name, and the max len is supported by a BERT, and the DistilBERT model is maximum 512 max len. So that is I'm gonna select here 512 max len, and then it asks about the classes name. So what are the classes name? So these classes name are the categories which we had already selected. All right, so those are the categories. Thereafter, once you do that one, you get there a trans. All right, model name, and you pass the classes name, that is the target, and the maximum length of the tokenization is 512. All right, now let's go ahead and get the train data. All right, so the train data is a mix of X train and the Y train. There I'm getting here a trans dot pre-process. All right, so pre-process training data set, and there I'm gonna pass X train and then finally Y train. And similarly I'm gonna say here the test data is equal to trans dot pre-process test data, and there once again I have X test, and then finally I have Y test. So with this I get training dataset and test dataset prepared for the transformer model. All right, once it is done, thereafter I'm gonna create there a model is equal to trans dot get classifier. That's mean now it is going to get the classifier of DistilBERT. All right, so it is going to get the DistilBERT classifier. Once we get this model, now we need to get their learner. So the learner is equal to ktrain dot get learner, and in that I'm gonna pass here a model, and then the training data is equal to train data, and then finally I'm gonna set here the actually validation data. All right, so this val data I have given the name for this validation data as the test data, and the batch size which I'm gonna use here, that is the 16. All right, let's go ahead and get the learner. Now once you get this learner, now we have reached at the final stage. In the final stage, we can train our model. But the always problem, there is one problem. The problem is, how do you know that? How do you know that which learning rate is fitting best for your task? And that you can get with learner dot lr find, and there I'm gonna say so plot is equal to true, and then max epochs I'm gonna set here 10. All right, although so it will take a lot of the time, so for that purpose I'm not going to run for all the epochs this lesson. So I just this cell, I just wanted to tell you that this is a code which you can use to find out the best learning rate. All right, so I have already run this code, and I know that there is a learning rate which is around 10 power minus 4 is suits best for this problem. So I'm just gonna select that one. All right, so I'm gonna just stop it. Otherwise, as you see that it's gonna take 3 minutes per epoch. That's mean the 30 minutes only for this the LR plot. All right, learning rate plot. So I know that what is that one. But if you have any other data set, then you should run this one first to know that which learning rate suits best for you. So I'm gonna fit here the one cycle method, and the learning rate which I'm going to use here, that I'm going to use the minus 4. All right, that's the 10 power minus 4. All right, and thereafter I'm gonna just use it for one epoch. All right, do remember I'm just gonna use it for one epoch, but you can use it for multiple epochs to just improve the accuracy. Since we do not have much time, that is why I'm gonna just train it only for one epoch. Let's go ahead and run it. Now you will see that the training has started, and it will take around 5 minutes with the GPU on a Google Colab to train this model. So we are gonna just wait for some time so that it complete its training. All right, so training is done there. Now you can clearly see that one there. All right, and your learner is there. So the training is done, and at only single epoch we have got a 91% of accuracy. That's way too good. And validation accuracy is pretty much high than the training accuracy. That's mean there is a fair chance that you can train it for more number of epochs so that it can improve the overall accuracy. So overall you have got the idea how you can use the transformers model. You can also use other transformer models to train your text data. And now the time is to test the matrix. All right, test its error matrix. Let's go ahead and see it with learner dot validate. All right, so learner dot validate, so it's gonna take just a little time to plot the confusion matrix there. And once we get the confusion matrix, and just wait for a few seconds. I think it is doing internal validation and classification to get the confusion matrix. So that's why it's taking a little time. Alright, so this one is a confusion matrix, and I think the classes we have not got. So for the classes, we can pass there a class names is equal to categories. Alright, so these are the class name which is stored in the categories. So we are gonna just get those there. All right, now you have got there the labels as well, and the overall accuracy, precision, recall, F1 score, all those things. All right, there is average accuracy, which is 91%. All right, so this is how you can get the confusion matrix. And apart from that, let's say you want to know that which are the data which is not performing good. All right, so for that one, you can say the learner dot view top losses and n is equal to 5, and there we have got pre-proc is equal to trans. All right, that's mean this was a transformer. All right, and now it is going to evaluate, and it's going to tell you that a top 5 rows, I mean top 5 data points which had performed which has performed badly. All right, so while it is processing, let's go ahead and make our way to predict the final outcomes or a target on a new data set. All right, so there I'm gonna just say that predict new data. All right, sorry, predict on new data would be much better. All right, so it says that these are the sum input which had a wrong output prediction. Like if you see there, we have this one 311. All right, so this 311 you can get like this: X test 311. That's mean this, and this input was actually the medical science, but it was classified as atheism. All right, atheism, and there is ID. This one, it was actually graphics. It was classified as a baseball. So these are the top 5, although you can change their n and you will get list of those top badly classified rows there. All right, perfect. Let's go ahead and predict on new data. So I'm gonna just use their predictor is equal to ktrain dot get underscore predictor, and there I'm gonna pass learner dot model, and then I'm gonna just pass their pre-proc is equal to trans. That means that was the object of a transformer. All right, let's go ahead and say that x is equal to, I want to say that here, Jesus Christ is the central figure of Christianity. All right, so I want to classify this text data, and I want to know that what is the target output, I mean what is the topic of this text data according to our model or according to our classifier. And in that case, I'm gonna say there the predictor dot predict, and just I'm gonna pass there x, and this is going to say that a wrong classification. It says that this is a baseball. All right, though this is not a baseball. All right, and apart from that, let's go ahead and take something else. All right, let me see something else. All right, let's go ahead and take some science related or medical related task, and even though I don't know if I put there, no, that's not right. All right, let's go ahead and take the another one. So I'm just gonna take a medical related, this one. So I'm gonna just put it into a double quote, All right. Perfect. So this one is medical related. That means the science medical. We should get the result. All right. So it's something like this. All right. So as we are getting only the 91% accuracy, so that there are 10% chances that our the input might get misclassified. But as you see there, our training accuracy is only 82% and validation accuracy is 91%. That means you can train it for more number of epoch to get the better accuracy. All right, superb. And apart from that, I think we have covered almost everything, what you need to know. That the final task, I mean the final point in this is that how you can save your model. All right, that's mean how you can save your model so that you can use it for a later purpose. Otherwise, one more thing, let's say if you want to know explanation about your predictor, I mean about your model, how you can do that, you can just write there predictor dot explain x. All right, that's mean it will do the classification and then it will do, I think this one is not installed, that is why it is not coming. All right, so in that way we can actually we can ignore this one, not an issue. All right, the final one is if you want to save this model, you can save it like the predictor dot save, and then you can provide the path where you want to save this. And I'm just saying that the model. All right, let's go ahead and run this. Now you should be able to see that model here. All right, so this model is stored there. Even if you want to give it another model, like let's say DistilBERT model, the name, so you should be able to see that here as well. All right, so there, this DistilBERT model. And if you try to download it from here, you won't be able to download it. So you can download it one by one file and then you can place it in a single folder like this one. All right, so all these files will be downloaded. Overall the size of file for this DistilBERT model is around 200 to 300 megabyte. But do remember, if you select any other models, those size may vary from 1 gigabyte to 1 gigabyte to 2 gigabyte. All right, perfect, superb. So this is all about in this lesson. Thanks a lot for watching it. I'll see you next lesson.